Have you ever experienced an application that just drags its feet, slowly churning through data while you wait impatiently? Often, the culprit hiding behind that sluggishness is not the application itself, but the database it relies upon. Common database performance bottlenecks typically fall into a few key categories, including input-output operations, inefficient queries, poor schema design, inadequate hardware resources, and improper indexing. These issues can drastically slow down data retrieval, storage, and processing, leading to frustrating delays for users. The primary reason these bottlenecks occur is a mismatch between the demands placed on the database and its capacity to respond efficiently. For example, input-output bottlenecks arise when the database system cannot read or write data to disk fast enough to keep up with requests, often due to slow storage devices or a high volume of concurrent operations. Similarly, complex or unoptimized queries force the database to scan through vast amounts of data unnecessarily, consuming excessive processing power and memory. Poorly designed database schemas can lead to data redundancies and inefficient joins, further exacerbating these problems. Understanding these underlying mechanisms is crucial for effective diagnosis. To effectively identify these performance inhibitors, start by regularly monitoring your database's key metrics. Look for high CPU utilization, excessive disk activity, long query execution times, and lock contention. Tools like performance monitors and query analyzers can help pinpoint exactly which queries or operations are consuming the most resources. From there, you can begin optimizing specific queries by adding appropriate indexes, rewriting inefficient SQL, or even denormalizing parts of your schema if logical data separation is not critical. Consider upgrading hardware resources like faster solid-state drives or more random access memory if monitoring confirms physical resource limitations are the core issue. One insightful concept here is the 80-20 rule, often applied to database performance, where approximately 80% of the performance problems are caused by 20% of the queries. Focus your optimization efforts on these critical few. Also, be aware of the difference between logical and physical input-output. Logical input-output refers to the data blocks read from the cache, while physical input-output involves actual disk reads, which are significantly slower. Minimizing physical input-output is a prime goal for performance tuning, often achieved through effective caching strategies and indexing. Ultimately, recognizing and addressing database performance bottlenecks transforms a slow, unreliable system into a responsive and efficient one. By systematically monitoring, analyzing, and optimizing your database environment, you ensure that your applications can access and process data swiftly, providing a seamless and satisfying experience for all users.
If you love understanding how the web works, like, subscribe, and stay connected with us.